So this is a restoring force. So restoring, what is a restoring force? This is the force which is creating inside the body as a reaction to the deforming force. So you see, as you have seen that as you wanted to increase the distance between these two molecules, so you applied a force in this direction. This force is called deforming force, and as a result of this, the body got deformed. Okay, now and because of this action there will be reaction produced inside the body. So as soon as you release this force is removed. Okay, then what will happen? This particular thing, the two molecules which were in excited state, because you see, initially I told you that when there are no forces applied, they are in equilibrium. So what happened, their potential energy is a minimum potential energy state. But when you have stretched them out, you have done some work on the body, you have done some work on the molecules, and which has increased their energy. Fine. So the molecules have now energy which is more than the minimum potential energy. That means they are not in equilibrium state. Now they want, so as I told you that everything in the world wants to be in a minimum equilibrium, minimum potential energy state. So as soon as this force is released, what will happen? The molecule will try to go back to its original position. Okay, this molecule will try to go back to its original position. Fine. And to bring back the initial distance between them. Listen to me very carefully. Okay, so when you release this force, then what will happen? They will try to come back to its original position, but then also they will have to do some work, isn't it? So they will come back to their original position by at the expense, by using the extra energy that has been supported, given by this force. Okay, that the work, extra energy that has in terms of the work done by this additional force, sorry, the deforming force. So while going back, the molecules will use that extra energy to do work to go back. Okay, so that means the force generated in this direction during this course of action is called restoring force. Okay, so restoring force, and so we have got to know about two terms, that is deforming force and restoring force. I would again like to tell you about it. See, suppose these two molecules, okay, they are bound to each other, they are also bound to other molecules. Fine. So you applied some force in this direction, so this is deforming force, is it? So when you applied this molecule came to this position. Sorry. Okay, you just applied this in this molecule came to this position. Okay, so what will happen? Initially the distance between them was this. Now the distance between them is this. Is it? So when it was at this position, it was in the minimum potential energy state. Minimum energy. Okay, but when it came to this stage, what will happen? The force has done some work on this particular molecule to stretch it, isn't it? So work done is nothing but energy. So it has, this work is done on the body, fine, by the force. So now at this stage, the energy is not minimum, it is minimum energy plus something else. So it has more energy. Okay, and this energy is given by nothing but the work done by this deforming force. Are you getting? So at this stage, the molecule is in the excited state because it has more energy. So as I told you that everybody in the universe wants to go back to the minimum potential energy state. So it will try to get rid of this. Okay, so how to get rid of this? It will again go back to its initial position. So while going back, the molecule will have to do some work. Okay, earlier work was done on the molecule, now molecule will have to do some work, and it will do some work. To do work, what you need energy, and from where this energy will be taken? From this extra energy that has been supplied by the deforming force. Okay, so during this course of action, a reactional force is created, that is called restoring force. Okay, now the thing is that, suppose that this is a molecule, this is the molecule, they are attached to other things. Suppose that the deforming force is equal to restoring force, is exactly equal to restoring force. Then what will happen? Okay, then what will happen? The molecule will go back exactly to its initial position. So suppose it has come back or come to this position. If F deforming is equal to F restoring, okay, then what will happen? It will go back to its initial position. Okay, and the body will retain its original configuration. Only original configuration means shape as well as size. Fine. But sometimes what happens, they are not equal. Okay, deforming force may not be equal to restoring force. Means suppose you have if you have stretched the molecule up to this, okay, but the restoring force created is not equal to this. So will it go back to its initial position? No, it will stop somewhere here. Okay, so it will create a permanent deformation. Are you getting? So if they are not equal, then there will be a permanent deformation in the body. So two things, see, if both the forces are equal, then what will happen? It will come here and it will go back. Okay, so there will not be any change, permanent change. Okay, so that is one case. And another case, what will happen? If the deforming force is not equal to restoring force, then what will happen? It will come here. Okay, but when it will try to go back, because while going back it will use restoring force, so it will not go back totally, it will stop here only. Okay, so there will be a permanent change. Okay, so this type of materials in which this deforming force is exactly equal to restoring force and there is no permanent deformation created, that is called elastic material. Okay, so elastic material, if you ask for examples, you know that steel. Can you change a steel easily? No, there is no permanent deformation created. Okay, similarly iron. Okay, if you want to change the shape and size of iron, you will have to apply lot of force. Okay, similarly if I consider rubber is also elastic. Okay, because if you stretch it, it's okay, but if you release it, it will come back to its original shape size. Is it? That is called rubber. Okay, and this case where permanent deformation is created because restoring force is not equal to deforming force. Okay, so that material is called plastic. Okay, plastic material, like you know that like putti and atta dough, you know that now if you make a dough of this atta or flour to make chapatis, so you can give it any size. Okay, it will take it, it will not never come back to its original position. You can't make chapatis out of rubber. You can make chapatis out of atta only, or this flour only. So that kind of thing, yeah, or you can say that glass or any wooden thing, that is also plastic. That means there will be a permanent deformation.